Good morning, everyone. My name is Rosanti Solidio, and today we'll tackle all about Northwest Corner Rule, finding a least common method, and the Maldi method. So, it is under Chapter 9, which is Transportation, Assignment, and Network Models. The transportation problem deals with the distribution of goods from several points of supply to a number of points of demand. Usually, we are given a capacity or the supply of goods at each source and a requirement, which is the demand for goods at each destination, and the shipping cost per unit from each source to each destination. The object of such a problem is to schedule shipments so that total transportation costs are minimized. At times, production costs are also included. So to elaborate further, we have here a diagram which is the different sources and the different destination of the goods. On the left side, we have the supply or the amount of goods readily available. And the demand is the amount of goods required by each destination. So as you can see at the arrows, it has 543 in the Des Moines source one. So it costs $543 for each transport of supply. And the Evansville, it has $843, and the Lauderdale has 97 and $5. So the cost of transporting supply to meet the demand varies among sources and the destination. So here we'll talk about the Northwest Corner Rule. So the Northwest Corner Rule, or NWC, is a simple, quick method for finding an initial feasible solution to a transportation problem. It is called Northwest Corner because you start at the top left cell or the northwest corner of the cost table and allocate as much as possible. Then move right or down based on the remaining supply or demand. So to elaborate further, we'll talk about the step-by-step process on how to do the Northwest Corner Rule. So how to apply the method step by step. So we start at the top left cell of the cost matrix, allocate the minimum of supply or demand to that cell, subtract the allocated value from supply and demand, and if supply becomes zero, move down to the next row. If demand becomes zero, move right to the next column. Continue until all supplies and demands are satisfied. So the the diagram I just gave you earlier, it'll look like this if you use the northwest corner method. So as you can see, on the top corner is the three destination: Albuquerque, Boston, Cleveland, and the supplier are the Des Moines, Evansville, and Fort Lauderdale. So the numbers in the 9 by 9 matrix here is the cost for each the cost of transportation for each supply. So to do the northwest corner method, we'll start looking first at the northwest corner, the number 5 or $5. So since we have 300 demand and we have 100 supply, we'll allocate 100 all of the entire supply of the Des Moines to Albuquerque, turning the supply into zero and the demand into 200. Next, we'll allocate, since the demand still needs 200, we'll allocate 200 from the 300, and then the demand turns to zero. So as you can see, the supply left in Evansville is 100. So next, for Boston, we have 200 in demand. So what we'll do is allocate 100 of the supply from Evansville into Boston. So we took 100 of the supply from Evansville, so the supply of Evansville is zero. Next, we still have 100 demand, so we'll allocate 100 from the supply of Fort Lauderdale to Boston. We'll end up with 200 left for the entire supply. So since Cleveland's demand is 200 and the supply from Fort Lauderdale is also 200, it just cancel each other out. Okay, so this is how to do the northwest corner method. So to finish it all off, we need to multiply everything. 100 by $5, 200 by $8, 100 by $4, and 100 by $7, and also lastly 200 by $5. So allocate it all: 500 plus 1,600 plus 400 plus 700 plus 1,000. We end up with a total cost of $4,200. Next, we'll talk about the advantages of Northwest Corner method. So as you can see, it is very simple and easy to apply. No calculations need except comparing supply and demand. It is good for beginners and quick preliminary solutions. It is fast and systematic, works efficiently even with large problems, and always produces a feasible solution. It ensures all supply and demand constraints are met. So we'll talk about the disadvantages. It does not consider cost. It ignores the transportation cost, so the solution is often not optimal or even far from optimal. May require more iteration in MODI or stepping stone methods to be discussed in the upcoming reportings because the initial solution is not cost efficient. Optimizing it might take more steps. And lastly, it can give extremely high cost as initial solutions, especially when high cost cells are located in the northwest. So next, we have another method which is called the least cost method. So the least cost method is a technique used to find an initial feasible solution for a transportation problem by choosing the lowest cost cell first. Instead of starting at the top left corner like northwest corner, as I discussed earlier, this method starts with the cheapest transportation cost, aiming to reduce the total initial cost. So here's how to apply the least cost method. First is we need to look for a cell with the lowest transportation cost in the entire cost matrix. Then we allocate the maximum possible quantity to that cell, minimum of supply or demand. Next, we reduce the supply or demand accordingly. If supply becomes zero, cross out that row. If demands become zero, cross out that column. Move to the next lowest cost that is still available or not crossed out, and repeat until all supply and demand requirements are satisfied. So to explain further, we need to look at the example I've given a while back. So using this, we'll solve for the least cost method. So the same way, we'll look at the 9 by 9 matrix. So as you can see, the Des Moines and Evansville transportation costs to Cleveland both have $3. So we need to allocate as much of that as possible. So I chose the Evansville and allocated 200 units to meet the demand of Cleveland instantaneously. And the entire column it got crossed out since the demand for Cleveland has been met. So next we look at the next lowest cost for transportation, which is the Boston in Des Moines and Evansville, which has a transportation cost of about $4. So we allocate 100 by 100 to Des Moines and Evansville since the supply for Evansville and Des Moines already is just 100 each, and the demand is 200. So we allocate those, and then we need to look for the next. But since the only supplier that's left is Fort Lauderdale, we ended up with allocating 300 of the units from Fort Lauderdale to Albuquerque. So here is the total cost: 300 by $9, 100 by $4, 100 by also $4 and 200 by $3. So summing it all up, we ended up with $4,100. So we'll talk about the advantages of using said method. So results in a better initial solution than northwest corner. Because you chose based on the cost, initial cost is usually much lower. More efficient starting point for optimization methods. MODI, or also called as U-V method or stepping stone, requires fewer iterations. It is simple and intuitive, and you only need to compare cost and allocate depending on the demand or the supply. So the disadvantages. It is a lot more time consuming than northwest corner. It requires scanning for the lowest remaining cost repeatedly. Still does not guarantee an optimal solution. Although better than northwest corner method, the result may still be far from the minimum total cost. This possible ties. Two or more cells may have equal lowest cost. You must break ties manually. So from the example a while back, since the destination of Cleveland and Boston both have lowest transportation cost, I allocated them based on the supply.
Greetings everyone. I am Jennifer Chimanguyab and today I will be going to tackle about the MODI method. MODI method. The MODI method or modified distribution method, also called the UV method, is an optimization technique used to improve an initial solution to a transportation problem. It starts with an initial feasible solution, usually from NWC least cost method or VAM, and checks whether the solution is optimal. If not optimal, the MODI method identifies adjustment to reduce total transportation cost. How to apply MODI method? Start at the top left cell of the cost matrix. Start with a feasible solution, either northwest corner rule or least cost method. Number 2, compute the U and V potentials. Then compute opportunity cost. Select the most negative value. Form a loop. Adjust allocations and repeat until there are no negative values. Now let us proceed for the example problem. A company has 3 factories producing goods that need to be transported to 4 cities. The transportation cost per unit area given in the table below. With this example, the goal is to minimize the total transportation cost using the MODI method. We first find an initial basic feasible solution, then calculate the dual variables and opportunity cost to check for optimality. If the solution is not optimal, we iterate to improve it. The MODI method helps us find the optimal transportation plan, which in this case would tell us how many units to transport from each factory to each cities to minimize cost. So from the table we have 3 factories which represents our sources and along with our destinations are the 4 cities. Within the cell, considering these $8, $6, $10, $9 and etc. By analyzing this, where these were the transportation costs needed to be transported from our source to the destination. So the row 5 represents the demand for the goods and the column 6 represents the supply. As what I have said earlier, we have to start with an initial feasible solution so that we can check whether our solution is optimal, and then if we find it not optimal, then our method identifies or our method needs adjustment to reduce the total transportation cost. And then for the factory 1, city 1, let us assume 15 and 20 for factory 1 and city 2. We also get the same price for the factory 2 and factory 3. Considering our demand and supply, all we needed to remember is that we must exceed what is given for our demand and supply. Therefore, since our demand for the city 1 is 45, we assume 15 for factory 1 and 30 for factory 2. Adding this up would be 45. In contrast, supply also is as the same for the process for the demand. And now, as I have mentioned earlier, we have to create a variable u and v, which is u1 for row 1, then u2 for row 2, and u3 for row 3. Same process for the variable v. We have a v1 for column 1 and v2 for column 2, v3 for column 3, and v4 for column 4. Now we need to figure out what are the values for all of these u's and v's. And to use that, we have to apply the following formula, which is Cij equals Uij plus Vij, where C is the unit shipping cost for row 1, row I, and column J. Now we're going to find the value of U and V for each of the allocated cell. The first allocated cell, which has 15 units of these goods. This says that U1 and V1 must be equal to 8 when you add it together. So if U1 is equal to 0, V1 is equal to 8, so that 0 plus 8 is equal to the unit shipping cost. Now that we know U1 and V1, we can figure out all other U and V values. The next allocated cell, which has shipping cost of 9, and if there's V1 is equal to 8, therefore 8 plus 1 is equals 9, so our U2 is equal to 1. For the second allocated cell, or the F1C2, or the factory 1 and city 2, for us to get our V values, first is to add U1 into any value to get $6 from this cell. Therefore, V1 is equals to 6, since 0 plus 6 is equal to 6. The same process for all of the other allocated cells. Now what we do is use the following formula, Cij minus Uij minus Vij. We're calculating this for each of the unallocated cell. Since we have our first unallocated cell, which is the factory 3 and city 1, and also has a unit shipping cost of 14, then the U value of 4 and V value of V, which has a value 8 values. Then all we need to do is find the differences of this unallocated cell for us to be able to predict our optimal solution. Then repeat the calculation for each of the unallocated cell. So once we calculated these differences for all of the unallocated cell, we have to look at the values if there are any of them negative. What that means that if there are at least one negative value, we have not reached the optimal solution. And then by solving another assumption, the same process from the previous slide, we can get these results. However, since there has negative value in it, this means we aren't in an optimal solution. Again and again, by solving another assumption, we can get the results with the same process. And if we have to reach and get the positive values of all the differences from the unallocated cell, therefore we find our optimal solution. Lastly, to find the total shipping cost, we have to add up all the allocated cell that we find as optimal. Therefore, all of the allocated cell F2C1 that has 45 shipping unit multiplied by $9 Then add to another allocated cell F1C2 that has 10 shipping unit multiplied by $6. Again, then add for the allocated cell F3C2, F1C3 plus F2C3 and plus F3C4. So the final answer would be 1,830, and that was our total shipping cost. And now let us move on for the advantages of Modi methods. Number one is it guarantees an optimal solution. When we say guarantees an optimal solution, it systematically checks and improves until the lowest possible cost is reached. Then, more efficient than stepping stone. There, with this, there is no need to form loops for every non-basic cell. Only requires calculations for use, V's, and difference values. Then less computation work, and lastly easy to identify where improvements are needed. And lastly, for the disadvantages of Modi methods, here you must first apply a northwest corner rule, then the least cost method, and also the Vogel's approximation method. It is also not a simple calculation for beginners, and also log formation can be confusing and degeneracy issues may occur. So these extra steps needed when the number of allocation is greater than less than m plus n minus 1.